Hello, so good day. This is Anirban. So today I want to share my perspective on the model context protocol agentic design pattern. Although it's a communication protocol, but I would consider it agentic design pattern because it's becoming very important. More and more customers are adopting this, and I'd like to share my perspectives on why this is important. I feel so. As we know, the MCP product design pattern has a MCP client, the MCP server, and the client establishes a one-to-one communication with the server, and the server exposes various tools. These tools could be agents themselves, or it could be connecting to external systems like CRM systems, databases, exposes resources. This would be file system contents in the local server, or it could be some database contents. The way we write the code, it will work like that. It also exposes prompt templates using which one can run the prompts. So in my view, the MCP design pattern gives the maximum flexibility to the business users. Why? Because the MCP client here is actually an intelligent client. It has access to a LLM. In my case, the experiment that I will do, I'll have the Anthropic Claude Sonnet model. So the client can understand the natural language query of a user and invoke the appropriate tool on the server. It could be a combination of tools, it could be one tool, it could be multiple tools, but it looks at the appropriate tools and gathers the information and gives back the result to the business user. And this is the most important aspect I have seen, which is needed and fits in the why? Because I'd like to show us a simple situation. We have something very similar in the industry where the customers are trying to do a defect root cause analysis. Right? So they have some unique ID which identifies the defect or error scenario or error message, and the agentic system or the AI system look at various results from the various tools like the log retriever tool. It can retrieve the logs, it can go to the Jira tool, find out similar Jira defects, it can go to GitHub, find the history of the commits for those services which are in error, look at the CRM tool and various systems, and we can have a huge big prompt which combines the context from these various systems and gives a result to the user. But now what we are seeing is that different users have different requirements. So some user may say, I want to look at the similar Jira defects only. I don't want to look at anything else. Another user may say, I want to look at this particular data is available in this particular database or not, because it could be a data related issue. So various users are having various requirements. Now how do we satisfy that with one prompt? We cannot, and nor can we keep changing the prompts for different user groups. So MCP client has that unique ability. It can take the natural language query of the user. We are not doing any parsing. We can do, in what I am going to show, we don't need to do any parsing. It can find out which tools to be invoked, and it can extract the tool parameters from that. It knows intelligently what are the parameters to be supplied to the tools, invokes the tools on the MCP server and gives back the result. That is the unique ability of the MCP client. So the MCP client is intelligent. So what AWS is showing here is the MCP client connect to multiple servers. MCP server A, which talks to a local data source A, MCP server B, which has access to a data source B, MCP server C, which is connected through a web API to some other remote server. It could be a CRM system or anything. So this client which has access to a LLM is an intelligent client. For me, what I'll show just now is a Claude Sonnet model. So it can get the appropriate tool and give the results best. That is the unique ability. The MCP server can be in any language. It can be developed in Java, Python, TypeScript. It can be a Docker image. So it's a huge flexibility to develop these servers. And the important thing is to expose the tools, resources, and prompts. And the business user has the flexibility either to get the prompt and run the prompt, know what that prompt is doing, and say, okay, run this prompt, I want to see the result. Or he can say, give me this result simply, and it goes and invokes that tool. Or he can access the resources. He can say, give me the contents of this database, of this file system, That's also possible. The business user is getting the maximum flexibility. So different users may have different requirements, and they can do according to their own requirements and get the result they want. I think that is what the unique about MCP client server architecture, which is what I found. Flexibility to the business users and making it language agnostic and platform agnostic. So this MCP can run with any of the agentic frameworks today. More and more agentic frameworks are adopting the MCP framework. So as we can see here, AWS has released the support towards MCP. They are giving a particular architecture diagram how MCP should be used in the AWS ecosystem. So how the MCP client, and the MCP client is sitting here, the user is interacting with MCP client, and there is a layer of authorization, security, and then it connects with server and AWS Lambda functions and all that. So this is very important. This architecture is very important because it gives flexibility to the user, because the MCP client, although the word is a client, intelligent client, I think it should be called an MCP agent client or something like that, right? So that is very important. So that is the way business users can get the work done based on their individual preferences. Also, another important aspect of the agents is basically the agent should have access to memory, short and long-term memory. So this is an article just came out today in LinkedIn, and I saw this diagram. So a lot of agents, we are still using the memories, the short-term and long-term memory. So the memory, in memory, it could be using lang mem or a mem0 kind of a framework, and it can store even vectorized embedded information, and the agents can automatically load that information from the memories. And this could be procedural memory, this could be different types of memory. Like for example, it could be long-term memory, can be procedural, it could be episodic, right? There are different types of memory. It could be different types of memory, and all these cases, the memory is very important. So how the prompt can be updated dynamically using procedural memory, that's very important, right? So all these things, basically the article link is given here, and I think it requires some kind of a memory. So it requires some subscription. I think this part is free. Short-term and long-term memory, episodic memory, procedural memory. All these kinds of memories are there, and it should be, the agent should be able to hook on to that memory and update the prompts dynamically based on the user's choices. I think that is a flexibility that business users are looking for, not a fixed huge memory and there is a huge team, updating that prompt from time to time, trying to find the prompt. But whatever fine-tuning we do, it's based on one set of request from one group of users. The other group may not agree to that. He may say, no, I don't need all these things. I need a very simple thing. I want to look at only this source to make my decision. So how do we achieve that? We cannot make prompts for every user, right? So we need to have dynamic prompt generation. That is where MCP can help. That I'll go to my solution. Basically here I have my own MCP server, but I wanted to show this MCP server is a fast MCP. I have a server and I have two tools. One is search images. The search images, basically it looks at the images extracted from my PDF books. These PDF books are based on space science, which I've shown in my earlier tutorials. So I've kept those images extracted in 3 folders, and this going to that and getting the responses. The search web, what it does is it basically uses a web extractor. The code for extractor can be found in the web extractor file, and I'll give it a tabuli search. So it searches the internet. Now what I'm going to, it also has a MCP resource which lists the content of the folders. Short all books have been digitized and available for search in my local. Now what I'm going to start this server, right? MC. So the server has started in this. Now I'm going to open another this thing, and basically in this window I'm going to run the the chat. So it says type your query or quit to exist. Use @folders to see available books. So we say hi. So it says hello, I'm here to help you with your questions about space science. I also defined in my server. So @folders will give me the output of that. So it says there are 3 books available: the Lunar Survey, an Introduction to Space Exploration, and Solar System Exploration and India Contributions. Right. So I have these 3 PDF books written by the ISRO expert, Dr. Tirtha Pratim Das. So now I'm asking a query. Let's say, what is the Karman line? Tell me from web search. Tell me from internet search and include the URL. So I'm saying search this concept from internet, and give me the reference URL also. So I can see it is calling the tool search web, and it has known what is the parameter to be passed, and it says from searching the web I found this answer. The command line is an imaginary boundary and all that, and this is the reference for that. So I have these 2 tools, but it knew that I am looking for the answer from the search web tool. Now I didn't say search web, I said search the internet, right? Similarly, I can ask the same question. So now I search local documents. So we can see now it's calling the search images function. It knows that I'm looking for the local document, so it is going to call the search images function. And it's going to give me the result. So in that I'm using the Google Gemini Flash to go through the images and come up with the result. So it knows, the client intuitively knows which tool I'm looking for. That's what I was trying to show. So it says command line based on this particular document is at 100 kilometer altitude, is imaginary boundary, and this is the information I found on page 7 of the document, right? So now, of course, it doesn't say, it also says that there is some information about this on page 16. It doesn't say the name of the document because I haven't coded it that way. It's a continuous set of images. It is extracting the information from. So I could have done it a little better way to return the name of the document as well. So basically it knows what tool to access on the MCP server based on my query in natural language. It also knows what should be the parameter passed to the tool. I'm not doing any sentence parsing here or anything. I think that is the important aspect I wanted to show. I also wanted to show my experiment on running the MCP server with a custom made server. So here I'm using the GitHub server, and this is my GitHub server. So where I can say that all we need in the custom server config JSON is the command needed to start the server. In this case, our GitHub pre-built server, MCP server. So we can go to this MCP server context protocol /servers. We can see a list of pre-built servers. So I've taken up the GitHub server, and we just need to give this configuration, very simple, and we run the basically we run the server with custom. We open this server config custom.json and the server. That's it. So once we do that, basically we can query it. So let's run it. So it is connected, is the GitHub server has been connected, and these are all the tools available on the GitHub. So for example, add issue comment, fork repository, create issue, create request, get list issues, get issues, all the things that we can do with the GitHub are available here. what I was seeing is I can type in a natural language query, and the MCP client, since it has the Anthropic Sonnet as a background, can invoke that particular tool on the GitHub repository. For example, I can ask which list the most recent issues on the model context protocol. So let's see what it does. Sometimes my token runs out of limit, so in that case it may not be able to do, but let's see. So it says I'm first calling the tool search repositories with the ARG model context protocol. So I need to search for this repository, and then saying I'm calling to list issues with the. So right now I'm the rate limit has been exceeded for whatever reason. So but as we can see, yesterday I was getting the because I'm doing it for some time. The rate limit, I have a very basic token on the Anthropic. We can see here very clearly that it is calling multiple tools also. That's also possible. It called search repositories, and then it called list issues model context protocol, and this gives the result. I have my screenshots where I can see the top issues on the model context protocol repository, right? So in this case right now I have gone out of token limits, so it's giving. So because I was doing this earlier, so there is a token limit for the last 4 hours or something. So that's why. So this is what I wanted to show quickly. MCP project, very quick demo, and what are the capabilities of the MCP server, how it should be invoked. Basically, we connect a fast API client to the MCP client, and from there we can invoke the MCP server, maybe a Bedrock agent or other agent. So this sequence diagram has been given on the AWS. I'll give the reference URL for that also. And I wanted to show how MCP client server architecture fits in the business in various situations, because that is what the users are looking for dynamic query, not something very fixed which comes up with a fixed answer, fine-tuned prompt, but still a fixed answer to every query based on some input data and a fixed prompt. That's not where business is going. Business is looking for a generation of prompts. Business is looking for dynamic invocation of tools based on some intelligence embedded in the client. And exactly what the MCP client server architecture provides. Thank you.